Today what we're going to cover is, is KNX good for heating and cooling, or is heating and cooling good for KNX? It's an important question. What are the different types of HVAC? So HVAC covers quite a big range, and we're going to have a look at the different types. We're looking at aircons. What you need to know when you're looking to control aircons. I'm going to now have a short ETS demonstration showing you through some of the configurations and how to put together some of the different types of aircons. Then we're going to come back to the presentation and we're going to look at heating and cooling and what you need to know for that. And when we're talking about heating and cooling, that's everything except for air conditioning. After that, we're going to do an ETS demonstration with a heating and cooling, and we're going to look at a few ways that we can use two-step or two-point control and PWM and continuous control. And after that, we'll have some questions. Okay. So can we see the next slide, Ed?
Yes, perfect.
Okay, great. So is KNX good for heating and cooling? Well, to be honest, guys, KNX is from Europe. It has its DNA and its inception's been in heating and cooling right from the start. It's part of its DNA, and it has many manufacturer members from the HVAC industry that are members, and they've brought their technology and integrated as part of the KNX protocol. So I think a really important point here for yourselves and for your customers is KNX is not a lighting control system trying to do HVAC. HVAC is part of KNX. It's an important part of KNX, and it's a big strength of KNX. And as the energy efficiency debate and energy goes more and more, we see this becoming much more of a pull-through. Automation, one of the biggest drivers of energy efficiency, and heating and cooling is one of the biggest users. So it makes sense that we should be doing our best to control the heating and cooling in the building, and not just from an ongoing point of view where we can use our switches and that to control the heating and cooling depending on if we're home and stuff like that, but from a very from a holistic point of view when we're installing it, we have a lot less products because we can have a wall switch that can send temperature and do thermostat control as well as control thermostat logic. Not to mention we've got sensors and everything like that. So instead of having multiple systems in a building, we can have the one system that's controlling everything. Most KNX field inputs, which we're talking here, we're talking keypads and detectors and that, have temperature on board at a minimum, and a lot of the time they have thermostat logic built in as well. This is extremely handy. You have to get yourself used to the fact that the thermostat logic and the thermostat controlling of that logic may not reside in the same spot. It can be put in different places across the bus and make use of memory that's existing on your network. Correct programming and the synergy of all this comes together is the biggest efficiency we have. So making use of blind control along with the fact of conditional programming, such as people are home, it's winter, the biggest thing we can do to save energy and a true perfect job with heating and cooling in KNX is the customer not having to touch the air conditioning or the heating and cooling thermostat controls, and the building is just what they want at the time. So that is the ultimate goal. Creatures of habit, we are used to having to have control, and people need to know that they can control it. But the biggest aim for you guys would be to have the air conditioning or the heating and cooling, whether that be in other forms, automatically working at the correct times when it's needed and not when it's not. So not wasting air conditioning or heating power. Just having a look at some of the manufacturers I thought I'd put on here. These are all the manufacturers of KNX, and they all contribute in different parts to the heating and cooling and the products that are available. Amongst these manufacturers, there's many different types of ways to put together and methods of controlling heating and cooling. We have the likes of MDT, Fujitsu, Elsner, ABB, Intesis, Theben, Zennio, Gira, Cool Automation, Panasonic, and Dakin. So these guys are all active members in the KNX community. What's the different types of HVAC? Well, HVAC stands for heating, ventilation, air conditioning control, okay? So it's a broad spectrum of products and systems that belong underneath this banner. And there's many different products and adaptations to the way we can control the products, okay? So HVAC is basically, if you want to have a look at it on a minimal scale, is broken up between aircon and heating and cooling, okay? And then if we look at aircon, we could break that down into domestic systems and commercial systems, okay? And then with the heating and cooling, we could break down it basically into wall radiators, floor heating, or fan control, okay? And then just at the bottom there, we've got just some of the considerations and the things we have to think about, we have to involve when it's heating and cooling. So in domestically, air conditioning and commercially, we can look at things like gateways, which are system-to-system protocol translators. So what we'll see generally is an air conditioning gateway talking to, for KNX to air conditioning gateway. Interfaces, they're more one-to-one. So we're looking at controlling just an indoor unit with an interface. That could present itself as Modbus as well. In the commercial space, we see a lot of BMS, BACnet, and simple relay control. Okay, so that is just a relay to turn on the heating and cooling. We also have to consider things when we're looking at radiators and floor heats, especially with hydronic. We have to look at whether we're going to control the boilers, whether we can control the flow control. There's no point in controlling, whether you want heating and cooling if you can't call for the flow to happen as well. We also have different types of floor heats. We have electrical floor heat, we have probes, we have zones that we have to control, and thermostats. We have to consider fan speeds of fan coil controllers and 2 or 4 pipe systems. All of this, we also have to consider the temperature, the target temperature, and the room temperature, current temperature it's using. So let's dive a little bit into aircons. So aircon, what do you need to know? Well, what to know? It's always good to start with aircon and help us help you, that we can have a look at what the brand is, okay? The brand specific aircon, and when we're looking at interfaces or gateways, is really important. We also need to know the part number and the type of aircon it is. For example, is it a Daikin? Is this the part number? Is it a split? Is it a VRV? Ducted? These are important things we need to check for compatibility. There's many manufacturers that make many different air conditioning brands interfaces, and they differ from sometimes brand to brand, and they also differ from years to year. So a crucial part of deciding what air conditioning interface or air conditioning gateway you need is working out what the system is before. So check with the air conditioning installer to see how the setup is, how it's configured, what type of control it is, and what are the part numbers. Okay, that's really important. Also check how many indoors and how many outdoors. How are they wired? How are they joined? This helps us decide whether we're going to use interfaces or gateways. And it also helps you establish a mode master. So to give you a description of what a mode master is, from one condenser, and the condenser produces heating or cooling that pumps to the indoor units. The condenser can't be in heating and cooling at the same time. It can only be in one, either heating or cooling. With one condenser with multiple indoor units connected to that condenser, then you will have a mode master. And that mode master decides on whether that condenser is producing heating or cooling. And what we have to do then is ensure that all the other indoor units are set up as slaves. Are there local controllers? Are there central controllers? This is another important one, especially when we want to use KNX temperatures to send from KNX inputs such as sensors and switches to the air conditioning to decide what the target, how to get to the target set point. So for an example, with an air conditioner, we will tell it that we want it in heating or cooling or an auto mode. We will tell it what set point we want that room to be. And it will look either into KNX provided temperature, a return air temperature, or a wall controller temperature input to work out whether it needs to increase or decrease itself to reach the set point. And then we have considerations with local controllers to make sure that our local controller is usually a slave to the air conditioning KNX interface, because generally in a lot of air conditioning brands, only the master on the wall controller slave bus is the one can send the temperature. Okay, this is quite particular. So when you come across this, please don't hesitate to reach out and speak to us. We have a lot of experience with a lot of systems, and we're well supported from our manufacturers, so we can ensure we get the right thing for you. But make sure you have that information when you come to us. Also, the other thing to consider when we're looking at air conditioners is cost point. You know, if we could use air interface devices that are to walk to one-to-one, they may be simple to set up, but when you get to around about 7 or 8 of those, the cost price starts to become negligible, and then you start to look at maybe it's cheaper and easier to use a gateway interface if possible. The other thing we have to do is ensure that we have, it's always advisable that we have some form of wall controllers there. Now, the air conditioning interfaces or the gateways that we have will take full control of the aircon. There is no problem with that. The only problem comes with the demarcation when we're looking at the installers, and we want to ensure that the installers that install the aircon feel comfortable. Some installers don't want to use the KNX to go through and to maintenance or do any other kind of adjustments to the aircon. They like to have wall controllers. What we suggest is that you put that wall controller in the switchboard or in a cupboard somewhere that it's hidden. We don't want the wall acne on the screen, on the wall, sorry. And plus we can take full control for the customer without having to worry about that. Then we can have the local wall controller installed somewhere hidden that the other trades can use for maintenance. Then we have to consider what's going to be controlling this. Okay, it's all good now. We've got the air conditioner. We've got the full control and ability of the air conditioner. How is the customer going to control this air conditioner? What type of keypads with scenes? So a nice thing to do within rooms for the customer is to set a scene when you push a button. That turns your lights on, your blinds on, opens your blinds, sorry, turns your TVs on, any kind of comfortable things. It also can set scenes within the air conditioning interfaces or the air conditioning gateways. And this is a really simple, nice way to ensure that the room is set how they like it when they come in, without them having to go rumble through their phone or go looking for visualization. Another good way is visualization. This is a really good granular control for customers. They can do things like schedule, they can set their set points, they can see their fan speeds, they can set modes, and they have a full bi-directional control of the air conditioner. And also we have the scheduling. So some nice visualizations have the ability to schedule, so the customer can automatically set up their automatic scheduling for what they want. So I thought I talked a little bit about air conditioning interfaces or gateways, and we're going to have a look at a short video in a sec. I thought I would just display for you guys a couple of different examples of visualization that you can control air conditioning. So on the side here we've got the Gira, which I'm going to demonstrate in the ETS video, and that has a full air conditioning component. And those air conditioning components, the good thing about KNX is it doesn't matter whether you have an air conditioning interface, an air conditioning gateway, or an air conditioning component to control those. You can be guaranteed, thanks to the standardization of the definitions and the data point types, that you're going to have a matching compatibility with whatever you choose, as long as you've got the definition right. Okay, so on here we can see a Gira G1 screen, and that G1 screen has the ability, you can see there, to set points, display the room temperatures, set the modes, set the fan speeds. It can actually display back whether that's in heating or whether it's in cooling, and you can do scheduling on that. Moving along into the middle, we can see the Basalte setup, very similar, just a different graphical user interface. The beauty of the Basalte setup is the customer can hit the schedule button, which is on the top right hand of that screen, and they can actually see and set their air cons on different temperatures, different set points, depending on what time of day it is and what day of the week it is. And to the right, sorry, we've got the Zennio interface. The beauty of this is it comes already without a server, straight into the touchscreen. It's very Zennio are very reputable for their air conditioning and heating control, and so you have every element you need to control the aircon control, along with that switch, all of the switches to be able to control blinds, lights, intercoms, anything else that you need on the KNX bus. Okay, so in this first part, we're going to look at air conditioning interfaces. So these are the one-to-one. Generally, the air conditioning interface will talk to an indoor unit, and air conditioning gateways will talk to outdoors or the central controllers or the out parts of those. So I've just got a few to give you a few rough examples of options and how it all is very similar within KNX. The first one we're looking at is in Zennio. So Zennio are renowned for their air conditioning and heating and cooling control, and you're going to see a lot of that in our presentation today. And just two that I thought I'd just bring up would be a Panasonic one and a Daikin one. So in the Panasonic one, you know, we can hop in here. Another real cool feature of Panasonic, not Panasonic, of Zennio, is the ability for logic functions. Now, if you would come to our previous Zennio air conditioning interface webinar, you would realize that this can be used for things like zoning and stuff like that. So really handy there. We just go into it, we configure it like normal. We go through and choose whether all the options or how we have the options of it. And what I'm trying to show you here is just the generality of how it all goes together. And then we get our objects. Okay, so well, no matter what, we have the ability to turn it off and go to modes and stuff like that. So I'm going to jump through quickly to a Daikin one. So this one here is the Zennio Daikin one, and you can see inside the gateway, it's very similar. It's adjusted to suit the Daikin system, a little hint, subtle changes that are best suited for the Daikin compared to Panasonic, and they all have their idiosyncrasies. And you can choose whether you have flaps or non-flaps, and you know, type of fans and stuff. And you go through and set all these configurations. Then once you've done your configurations, you're left with your communication objects. So we've got the ability to turn on and off, set point, mode, fan speed, and I enabled the external temperature measurements coming through there. So what I did is I created some group addresses. I'll go to the next tab here. Basically what we created is some standard group addresses for air conditioning control. And those group addresses are as follows. And we link those to the air conditioner interface, and that we get full control of it. Okay. Going back again, I just wanted to show you the similarity and convention that's the same with Intesis, for example. So if you have a look at it in Intesis one, it's pretty much the same thing. It's just asking a different way, but it's very similar. So you don't get lost from brand to brand. It's asking you, you know, whether it's a P1 or P2, and whether it's a slave or a master, and you can enable different parts of the gateway to give you different functions. Yeah. One important thing I must point out here is you always have to enable what type of fan speed it is depending on the aircon. And again, we get these communication objects. They're very similar to the Daikin ones, to the Zennio ones. They're all those points over the same length data, so you know it's compatible. And you can see the point here that's used is 2105, like we previously saw. That's the same mode control for if it's Zennio, Intesis, Coolmaster. It doesn't really matter. So if we have a look at the modes here for this, will be 2105. Okay, yeah, HVAC control mode. Just to show you their Panasonic one, just so it's all familiar. Again, it's the same setup. It's just asked in a different way, different series of questions. I thought I'd just chuck Coolmaster in here. Even though Coolmaster can act as both ways, they've got it a little bit different. Basically, in their instructions, you put the indoor unit number in here, and then you enable the functions that you want. So if it's coming in from the bus, if it's going out from the bus, and what the feature is you're looking for, or the communications that you're looking for, and what you need. So you have to kind of build it a little bit, but it is particular and customizable. And once you've built that, then you get the communication objects out that what you receive. So we have the ability now to turn unit 1 on, get the status from set points and controls. Okay. So just lastly, finishing up, I just wanted to show you the similarity with the interfaces which we saw in the slide earlier. And I chose a couple different ones here, and one of them is the Gira one. So with the Gira one, we go into the Gira interface, and this is quite simple. Basically, it asks you to create a functional folder. I've created a functional folder. I've labeled it HVAC, and I could put more channels in that folder. So I've only got the one channel in that folder, and that's for the aircon. And in the aircon one, I chose the function to be aircon. Okay, pretty much all I did. I chose the icon and set point values, minimum and maximum, ticked a few boxes to suit my air conditioner, and then I've got the objects out. So the objects out we get it here, and we have the ability to turn it on and off. And you're going to find that all these objects are very similar and suitable and compatible with the objects coming from the manufacturers for the interfaces, right down to the data point types. So you can see here the mode is conducted over that 2105 again. So again, very compatible, quite easy. Okay, so when you have an air conditioning, as previously spoken about, that is one-to-many, then we can go and get a gateway. And the gateway essentially talks to the other systems protocol. And for this, the example we're going to show you today is an Intesis one, and they've just released the newest version that has the Dakin interface. So that hooks onto the P1, P2. What we do is we go to Intesis website, we download the map software, and we start a new project. Now I'm showing you with the Dakin version, but this is very similar across any of their versions depending on what you do. If we want to filter the type of device, we can go here. So we're going to use this one today, and it comes in a 4 indoor license, a 16 indoor license, or a 64 indoor license. Okay, so we haven't got it directly with us here, but it shows us a few different options here about how we can wire it and what required, but it's always a good idea to look in the instructions before you go. It is an IP connection, so you have to have IP to it, and basically we set up a few parameters like that. From there, we can click into the KNX connections, and it's always a good idea to give it an address of something that's in your range, so 1.1.22220 or something like that we'll use today. It has the ability to change the mode type. So like we spoke about, the mode types is really handy if you have something different thermostat that's controlling it. By definition, the KNX Association uses 20.105 data point type for all air conditioning air conditioning mode, and that is universal, that the value of 0 on a 1 byte command will enable auto, a value of 1 will enable heat, a value of 3 will enable cool, 9 and dry, and you get the operation. But if we had something different, like Control 4 used to have it a different way, they just had a standard 1 byte commands, which was 1, 2, 3, 4, as you can see there. So you have the option to choose depending on what you're going to. You have also ability to do different data point types and 1-bit controls and statuses. This is important here. If you want the ambient temperature provided from KNX for that air conditioning coming from KNX switches, you need to enable it here. And the fan speed is something you always have to consider as well. You know, are we looking at 1, 2, 3, 4 for our fan speeds, or are we looking at percentage? Okay, and obviously vanes and vertical and horizontal swinging. Okay, so if we go into our Dakin side, it's a really nice supported thing here. What we can do, we can actually just scan the bus. If you have the Dakin side hooked up and you have power to it, and you have
this all connected up, then you can just scan the network and find all the available units and the indoor numbers and all the rest of it. And you can always rescan it again after that. Because I have no Dakin system hooked up at the moment, I'm actually going to show you just a manual way. So we choose how many units we've got and the addresses of those units. And then we define what type of aircons they are, you know, whether they're VRVs or they're Sky or splits or depending on what there is on the network. So it's important to know all those things. Actually, you can always enable to consumption functionality there as well, and you can relabel those to suit yourself. So what we've got now, we've got it partly configured. So now we come to what we have, the signals, and signals is all the points that are available to us that that is supported through the InteSys gateway. And very similar to the likes of Coolmaster and that as well. So what we see here, they already have it addressed for you. So they have 0 address for on and off and status and modes and stuff like that. Now, I would suggest that you don't need all of these points, and you can pick and choose which points you really want and don't want. So you can go through and you can untick, you know, fan or status of indoor fan and all these kind of things that are just not required, and so they won't come up. And actually, you can do that in a bigger way. You can actually go through and highlight from top to bottom, you know, which ones you don't want, and tick them, and they'll all untick. Okay, so that's a quick little advantage you can do that way, and then you can actually hide those disabled signals. Okay. And then you just get the signals you want, okay? So the way we can change the group addresses, we can actually export this to an Excel spreadsheet, and we export it to a Excel spreadsheet. Then if you look at our other videos, hot tips and tricks, you can actually export your group addresses, copy them across, and import them back in and do it that way. If not, you can actually choose, you know, all your indoor units addresses, go from 1 to the top, choose 3 level, and then choose where your air conditioner is going to sit in what main, middle, and main groups it's sitting in. So just as a rough example, 0/4/0, increments of 1, and then it'll automatically address all those. Okay, so once you've got all your air conditioners addressed, and you can see if I keep scrolling, we can go to units 3, 4, and all those kind of things. Then what we have to do is we have to send it to the system. We have to send it to the gateway, and then we can diagnose it. So once we've sent it to the gateway, then we can see all the values coming up here, and we can actually go through and turn things on and off from here and look at things like that as well. Okay.
Okay, so that was the air conditioning. We looked at, you know, air conditioning interfacing, air conditioning controls, and air conditioning gateways. We gave you a little example of what those are. The second part of heating and cooling is the actual heating and cooling part, which is a lot of the time it's resigned to space heaters, wall heaters, which commonly known as radiators, which are fed through a hydronic system, electric floor heating, and fan core controllers. Okay, so what things do you need to know when you're just looking at general heating and cooling and not the air conditioning side of things? Well, you need to know what you're actually going to be controlling. We need to know if it's a floor heat, what type of floor heat it is, the fan core controllers, what size they are, what size the floor needs to be, and what type of controls you need. Okay, so electric, a lot of the time for floor heat, it's going to be a relay. So the relay is going to just turn it on, turn it off. Okay, and if your relay size is a little bit small, sometimes depending on the size of the floor heat load, then you can always put a contactor in that place. Another version of floor heat would be hydronic, or also the radiators work on hydronic as well. And what's important with hydronic is making sure you have the right valve types. Okay, so the valve types will usually come in something like a 0 to 10 signal, a 24 volt DC signal, or a 240 volt valve type. Okay. The other way we're looking at is fan core controllers or fan core units. Okay, and these are not the ones that we know, the generic brands that we've shown you the interfaces for. These are the ones that are running off the hydronics and running as part of a complete system. They're a little bit rarer in Australia, but they're certainly something that's being used around the world. And for that, we need to ensure what are the valve types. So again, 0 to 10, 24, 240 volt, and are they 2, 3, or 4-way valves? That's important as well, depending on what the control of the valve mechanism is in there. And we also need to know fan speeds and fan speed types. Are the fan speeds contact control, or are they 0 to 10? When we're looking at these kind of systems, we also need to consider, are we doing any boiler control or boiler notification? And are we doing any pump flow control? Okay, these are always so important. The next thing we have to consider is, what is our control strategy? Our control strategy is usually dictated to us via the type of valves, okay, that we're using and the control thing, but you still have to appropriate the right outputs for it. There's two major ways that we can control heating and cooling in our building, and that is 2-point. So 2-point is on or off. It's good for electrical or electric kind of loads. It's very basic, but it's not efficient. Because if you think of a 2-point control, what happens is you have a set point, you have a room temperature, and the room temperature is lower than the set point. So the 2-point control turns on, say, the electric floor heat. And the electric floor heat will heat up. And what it'll do, as soon as it gets to its set point or target point, then it's going to turn off. But as you know, with electric, there's a little bit of inertia there. So the set point actually keeps, well, the actual room temperature keeps rising for a little bit before it goes down. And then it goes down below the target set point, and then it get for about 1 degree, and then it turns off. And then it turns back on again, and it keeps going up. And this is a mixed kind of up and down wave that's not, it's very basic to set up. It's not as so efficient. Then we've got continuous PI or PID, which is proportional integer. And what PI is PI is a constant calculation from the last output to the newest input. And basically what happens with PI, the closer it gets, the more calculations it does, it starts backing off the continuous control of the valve or the load. Okay, so you can imagine you've got a set point and you've got a target, or you've got a room temperature. As the PWM, you've got two types of continuous, I should say again. You've got PWM, which is pulse width modulation, or a continuous, which is something between 0 and 100%. So if we look at the pulse width modulation strategy, basically it's a lot of pulses. So it pulses the load on and off, on and off, on and off, until it starts to see where it's increasing the room temperature closer to the set point. As this starts to increase to the set point, then the pulse widths become a bit smaller, okay? So it finally tunes the output to pulse less time and more less pulses to keep it closer to the output. So it's not busting over the target and then going under the target. It's just constantly keeping it within range, okay? Now, the other one we've got here is a continuous drive. So a continuous drive on a valve might be a 0 to 10 valve, for example. And that's modulating the signal continuously to drive the valve from anywhere from 0 to 100%. The same strategies can, or algorithm or formula is still employed. And what it does is actually, as the room temperature is far distance from the target, the valve will open 100%, say, because it's really trying to quickly reach the target set point. So as the room starts to heat up, it makes an evaluation on the way, and it says, well, actually, we keep going at 100%, we're going to shoot over the target, and that's not very efficient. So it starts to back off the valve, and it starts to drive the valve down, and it starts to drive it down to just so it just starts to touch the target line, and it keeps it within that. So the setup for that and the use for it is more complex, but it's much more efficient. And then we've also got to consider our zones and how we're controlling the zones, where our thermostats are and where our input temperatures are for these zones. With heating and cooling, there's 4 major parts to any heating and cooling system. There's the thermostat controller. Got to be careful at definitions here. And what I mean by that is this is the human interface or the user interface that decides what they're asking from the heating and cooling. Okay, so I want the floor temperature to be 23 degrees and I want it in comfort mode, and so forth. Okay, that is the input from the user. Then we've got the thermostat logic. So the thermostat logic and the thermostat controller sometimes can exist in the same product, but not always. Okay, you can have the controls for the thermostat and the logic for the thermostat in two different places, and we're going to show you what that looks like inside an ETS demo next. What the thermostat logic does, it takes into consideration maybe a room temperature. It could be a temperature coming from a switch, such as the Faraday switch we've seen there, or the Gira switch you've seen there, or it could come from a probe, okay, and a probe coming out of a floor or anything into the back of a switch. Basically, what it looks at is it looks at the probe temperature, it looks at what the customer's asked for, and then it makes a calculation and drives an output to reach that target, okay? And as one of the strategies are employed, as it gets closer to that target or it busts over that target, it turns that target down or modulates the signal to keep it within there. We've also got to consider room temperature. That could come from a wall switch or a probe. And to be honest, there's also a consideration with balancing the room temperature. You might want to take some of your temperature feedback to the thermostat logic coming from a switch, which is near a door, but you might want to only take 20% weight of that coming from the door and most of the weight coming from the roof, where it's less susceptible to breeze or anything like that. So just having a look at some of the inputs we use for heating and cooling, we have switches. Those switches, and I'm showing here, the one on the left-hand side is a lithos switch. So the lithos switch has a built-in temperature sensor that's built into the switch itself. If you just want to take the room temperature without having to worry about a probe, it will give you the room temperature. A majority of the switches do this for us, and decent type of switches. Of course, there's switches that don't have any temperature references or abilities at all. But interesting enough, a lot of the new switches, and in particular the lithos switch, has the ability to take in an external probe in the back. So it takes in the probe, and it's an NTC probe. That probe can sit underneath the floor or in the concrete or coming from somewhere where it's designed to be in the hydronic, and it can send the temperature and be calculated and scaled within the switch and sent out onto the KNX bus to a thermostat logic sitting somewhere else, or also the lithos switch has thermostat logic in, so we can use either or temperatures for that. I'm going to show you in the demonstration coming up that we've got things, a lot of our temperature sensors can reside in sensors, and in particular the Elsner intrasui sensor. And that sensor is a really good sensor. I'm going to leave it for the demonstration to show you that. But that sensor itself can have temperature and thermostats built into it as well. Now, you might be saying to yourself, it's a strange place to take a temperature. And the truth of the matter is the best place to take some temperatures in a room is on the roof. It has less interference from windows, doors, people moving and stuff like that. The only consideration we have to make sure we take into careful account is the fact of how high the roof is. So I'm about to go through that as well, but we usually offset the temperature in the room about 1 degree every meter in height off the floor level. And today we're going to be looking at the Zennio quads. So that is a quad plus and a quad rail 8. Basically, they have the ability to have the quad plus, which is the small square one that's not DIN rail mounted, has the ability for 4 thermostat probes to come into it. They can be any NTC probes, and it also has 4 not only temperature probes but 4 thermostat logics built in. And then we look at the far right, that is the quad rail, and the rail has the ability for 8, and that is the DIN rail mounted one. So what we're going to do in this demonstration is demonstrate a couple of things. Number one,
hydronic heating and the setup for hydronic heating. We're going to use, for the hydronic heating, we're going to use the HMT 12 and the Zennio, the Lithos switch for the thermostat. And then we're also going to look at electric heat control. And for electric heat control, we're going to use the RM4 and the Quad Plus as the thermostat. Now, as the thermostat controller, we're going to use the Gira PoE again, the Gira G1. Okay, and just at the end, I'm just going to talk a little bit about other places we can gather thermostats from and where they can exist, and also temperatures. Okay, so getting right into it, basically we'll start off with the electric floor heat, and for that I've chosen the Quad Plus. So the Quad Plus, as we saw earlier, is a unique device. It has the ability to take in a temperature probe, and also it has built-in thermostats as well. So I'll take you through the process of the setup for the unit. Basically, we have a look at the parameters, and we have the ability here to have 4 different probes come into it. Those probes are not automatically connected to the thermostat, and you're going to see why this is important soon. And we have also the ability for 4 thermostat logics. Okay, so 4 thermostats can reside on this device, and they can take their temperatures from different places. They don't have to take it from the Zennio probes or the temperature probes coming into that device. Okay, so for this case, we're just going to use a Zennio probe, but we could use a customized or a different type of NCC probe. Looking at the crux of things, we're going to the thermostat. So the thermostat I've just set up for heating. It could be a heating and cooling or a heating and cooling. We've kept it really simple, just one system instead of having 2 systems. And 2 systems means that you would have additional sections of heating and cooling. So, for example, if the floor heating wasn't getting to the target set point, then you'd have an additional heating stage, which may include an air conditioner or something like that. It's a little bit advanced for what we're doing today. Where we want to get our temperature from, we can get it from the one source, or we can proportionally get it from 2 different sources, depending on how we feel on the room, and we'll have a look at it later. Is the thermostat always on? No. So the difference with thermostat control, we talked about a bit earlier, is that in Europe, they don't have on and off. They just have different modes because they never want to turn their heating on and off. What they want to do, their off mode is actually building protection, and that just stops their pipes from freezing in winter, even if no one's in the house. Okay, so that's why. But in Australia, because we have air conditioning, we're used to turning things on and off. So customers like that, we do have that ability to set the thermostat as on or off. Okay, so going straight along, easy to keep the set points absolute, no problems there. Most of this is default. We can have things like windows, turn it on and off, and comfort modes extended and things like that. So coming down to the type of control we want, because it's electric, there's only 2 positions that the thermostat can do, and that's turn the electric floor on and turn the electric floor off, and that'll make the decision depending on the target set point and the current room temperature. Okay, so what I did, I went ahead and made some group addresses, and I attached those to group addresses. So I've got the ability here to turn the thermostat on and off. Okay, we've had the ability to change the modes here. We have the ability to set the set points from here. Okay, we also have the output that's going to drive, in this case, our RM4 relay, and that relay is going to be joined to that so that when the set point's below the target, it's going to turn on, and when it gets above, it's going to turn off. Okay, and you can watch that happen. Now, take big note here. This is where I'm talking about. This is the actual input of the temperature probe, and that's the temperature source for the thermostat logic. Okay, so they both are in the same group address. I know it sounds funny, but in this case, the KNX look device sees them as 2 different parts to the device, so you have to link them. Don't automatically assume they're already linked. Okay, and then the final part of the piece for this is just our RM4H relay, which is a 25 amp relay. Now, if you exceed that relay loadage, then you really need to look at having contactor or something like that. And that part's quite simple. All we do is put in a group address, and that group address we have linked to that group address is the output of the thermostat logic, so the control. And this is telling us when the relay's on and off, okay? So now if I go and have a look at linking that to a thermostat controller of such, or a way we're going to control the thermostat, I've gone to the Gira again, and what we've done here is we've increased our abilities in the HVAC control, and basically I've put an electric, hydronic and electric floor heats in. Okay, so I'm looking at the electric floor heat, just set it up as normal. I called it a room temperature, but this time I've done it with a on and off ability. Okay, so we will be able to turn the thermostat off, which inherently will turn the whole control off for the heating or in stage heating. Okay, so if we look at our objects, and I'll go to the channel viewer for it because it makes it much simpler to look at. So I've got those same group addresses. Oops, I apologize. I've got those same group addresses now, and we've got the same ones that are linked to the Quad Plus. So that is the ability to turn the thermostat on and off, and if the thermostat's turned on and off. We have the room temperature, so that can display on the visualization of what the room temperature is. Okay, the heat, you can do set point and the set point status, and obviously the mode and the mode status. And this is the interesting one here. This is the electric relay control status. If I open this up a bit, you'll see here. And that's actually telling the Gira visualization whether there is heating currently at the moment or not. So you might have the set point set and the thermostat turned on. Is the actual floor heating up, or is the floor cooling down, or is it heating up or cooling down? And that comes off the status from the relay. Okay. Let's go back a step now and have a look at how we do it with hydronic. It's very similar. This time I've made it not turn on and offable. And what we've done here is we've used the HMT to drive the valve control. Okay, so we're looking at you know, a 0 to 10 type of valve setup for this. And also I'm using the thermostat logic behind the lithos switch as we saw in earlier slides. Okay, so going to the thermostat again. We have a normal switch here, and it has the function ability to bring in temperature from the sensor inside the switch, but also the same as the Quad Plus, it has the ability for that probe to come into it. So they also have to make sure that they're linked, or they're actually inside receiving the same temperature. Okay, so in the thermostat settings, quite easy. We're not using it as a fan coil controller. We're not using any special stages. We want to use the modes and automatically put it in heating and cooling, even though we're only going to use we can use the heating or cooling mode for the floor. The mode on download, it also has the ability to turn the thermostat on and off, but we're not enabling that at the moment. And window contact. So the window contact's really handy for energy efficiency. Almost, you don't want to keep heating your house if you've got some windows open and things like that. So set point, again, it just tells me the deadband, so the parts where it's not going to be reacting between the set point and the target points. And these are all the modes. When it goes to modes, where the values will go to, the set points will go to. Okay. Now we have a look at the heating control. So for the heating control here, the type of control we're going to do is integral proportional control, which is continuous. And that means the valve can drive between 0 and 100%. You know, if we were doing electric or something like that, we could use 2-point, or we could use 2-point or pulse width modulation. And depending on your proportional or integral thing, you can choose, you know, it's floor heating, so 5 degrees over 240 minutes. And very similar with the cooling control. Set point adjustment is quite simple. We can allow how far they can allow adjustment and how you want to see that. Do you want to see it in a 1-bit increase or decrease, or 2-byte float, which is standard. Okay. The objects we then get is, if we have a look at this, we have the ability to have the room temperature shown. Okay. We also have the ability to see when it's in heating or when it's in cooling. Okay. We have the ability to put it in and out of modes. Okay, and then the mode status. We have the ability to change the set points. Okay, that's how we change the set points. And then we have the control of the valves. Now the control of the valves is important, and that's a 0 to 100% control of the valve for the heating valve and the cooling valve. Now, because the thermostat's all built in one for heating and cooling, it won't ever do heating and cooling at the same time. It'll do a mixture of heating and cooling, or just heating or cooling, and depending on what it is. Okay. Now, if we look at the output side of that, then we've got the HMT12. And so it's quite simple setup for the HMT12 here. We've just gone into the parameters and just said this also has the ability for to be a controller or just an actuator. So the type of actuating we're doing is continuous because it's a 0 to 10 output, and we've got the 10 to 0 one out chosen here. We can see a little bit of adjustment for the valve, and the pump control is really important via the relay on the board or via the second or that. So we can actually control pumps and flow with this, boiler, sorry, and flow pumps, okay? And the pump control is down here. Now, it was as much similar setup as it was for the cooling. It was exactly the same setup for it. So, and now we have a look at those objects. These are quite easy. The continuous control value, and that is coming from our thermostat, is in the same thing as the thermostat. So it's driving the thermostat from 0 to 100% depending on how hard it needs to reach the target. And then we're getting a status back on how hard that's going, and the same with the cooling, how hard it's driving the cooling and not driving the cooling, okay? And that's using continuous PID or PI integral, okay? So having a look at that differently inside the Gira is we've got the Gira set up here, and we've got the second one, which is for the hydronic. And the only difference really I've done with this is we're not going to make it turn on and off. It's just a room temperature controller, and there's no on and off thermostat. So the only way that can set it off is putting it in standby, or sorry, in building protection mode. Okay. And if I have a look at that in the hydronic, then we can see we've got the room temperature coming through. We've got the ability to change set point statuses, mode, changing the modes and the mode statuses. And then this is another one. This is the heating message telling us whether we're in heating or we're in cooling. Okay, so just before we end this part of it, I thought I would just show you a few different places where we can conceive or we can have other temperatures coming from other switches. So if we look at our really favorite switch of mine is the Faraday or the Alpha, and inside that also has the ability for temperature. Okay, so we can have it adjust the correction of it depending on how high you've got the switch, how often it sends out its values. Okay, and then we can link this to any of our inputs for our temperature or our thermostat controllers, or we could put it into another group address to weight it for input 1 and input 2. Okay. Just as a side little thing, another really cool product, and Elston's one of our really great manufacturers, is the Intrasui, and we saw that in the slides previous. Basically, I wanted to show you that it has a heap of functionality in it, and what that functionality does allows you brightness control, threshold brightness and detection and all those things. And the real cool thing is humidity and humidity control if you've got fans in bathrooms. But it also has a temperature thermostat control as well. Okay, so it can also send temperature on the bus. And believe it or not, one of the best places to take temperature is actually on the roof, because it's not influenced by opening and closing doors. It's not near a window. It's not anywhere. So it's a very stable place. The only thing we have to remember is the offset. So every meter of height in the room that we go is 1 degree added. So if you think about a wall switch is 2 meters lower than the sensor in the room, then that will be 2 degrees offset, roughly we're talking here. Okay, and then we can set up a thermostat in it as well. So it can actually be a full thermostat in the mode and everything like that, to type of stage of heating and everything like that. It's the same values, the same setup as what you've seen in other things. It may have different kind of meanings or, wording and stuff like that, but essentially it's all the same. And this is just part of the thermostat logic that you can have inside a sensor that's on the roof, you know. And now we have the ability to do modes, we have the ability to do set points, and these are all same data point types, same length of data that can be joined to any of the group addresses that I've already done. It just needs your parameters and differences.